Just 100 years ago, humanity's grasp of the cosmos was remarkably limited. Most astronomers believed that all of existence was confined to the Milky Way galaxy. However, in 1928, Edwin Hubble overturned this belief through precise observations, revealing that the universe was not static but expanding. This breakthrough fundamentally changed our understanding of the cosmos and marked the beginning of a new era in astronomy. In 1997, the Hubble Space Telescope made another astonishing discovery. It found that the expansion of the universe was not decelerating as previously assumed, but actually accelerating. This acceleration appeared to be driven by a mysterious force now known as dark energy. This led to the current estimate of the universe's age, approximately 13.8 billion years. However, new data from the James Webb Space Telescope, JWST, is now calling that timeline into question, challenging long-standing assumptions about the origins and structure of the universe. Within the Milky Way lies a star cluster called M92, which has left scientists baffled. This dense group of ancient stars appears to be nearly as old as the universe itself, about 13.8 billion years, and in some estimates, even older. This raises a paradox. Stars should not predate the universe. The data from M92 confronts our most fundamental theories. Using advanced modeling, astronomers created over 20,000 simulated star populations to estimate the cluster's age. The results suggest an age so close to the universe's origin that it raises a critical question. Have we misjudged the timeline of the universe? Enter the James Webb Space Telescope, the most powerful observational instrument ever aimed at the cosmos. It has looked deeper into space and further back in time than any telescope before it, discovering galaxies that existed just 300 million years after the Big Bang. But what's most surprising is that these galaxies are much larger and more mature than they should be, considering their early place in cosmic history. This observation hints at the possibility that the universe might be significantly older than previously thought. The combined mysteries of these early, massive galaxies and the age of the M92 cluster have led scientists to entertain the possibility that our understanding of cosmic history may be incomplete. A radical new theory proposes that the universe might not be 13.8 billion years old, but rather 26.7 billion. This hypothesis suggests that key aspects of our models of cosmic expansion and early galaxy formation could be fundamentally flawed. Evidence supporting this possibility comes from several sources. One of the most compelling is a star known as HD 1.0283, commonly referred to as the Methuselah star. This star is estimated to be about 14.5 billion years old, nearly a billion years older than the accepted age of the universe. According to current stellar evolution models, this shouldn't be possible. Stars age in predictable ways based on their size and chemical makeup. Yet the Methuselah star appears to be aging more slowly than the universe around it. This anomaly doesn't just challenge our numbers. It calls into question the very foundations of our understanding of cosmic history. Central to this debate is the value known as the Hubble constant, which measures the rate at which the universe is expanding. This constant is vital to estimating the universe's age. However, different methods of measuring it yield conflicting results. Observations based on the cosmic microwave background suggest an expansion rate of 68 kilometers per second per megaparsec, while local measurements using nearby galaxies and stars suggest a higher rate, around 73. This inconsistency, known as the Hubble tension, continues to puzzle scientists. Without a universally accepted value for the expansion rate, any estimate of the universe's age remains uncertain. Some scientists speculate that the root of the problem may lie in unknown aspects of physics, perhaps in how dark energy behaves or in forces we have yet to discover. One of the JWST's most groundbreaking contributions is its ability to peer into the cosmic dark ages, the period before the first stars formed. What it has revealed is extraordinary. Just 300 million years after the Big Bang, galaxies with alloys, sizes and structures similar to the Milky Way were already in existence. According to standard models, such galaxies should have taken billions of years to form. These findings raise profound questions about the completeness of the Big Bang model. If galaxies existed in such mature states so early, is it possible that our timeline is missing something essential? The growing list of anomalies has led some researchers to entertain even more radical ideas, such as the possibility of a multiverse. In this view, our universe may be just one among many, each with its own set of physical laws and timelines. If this were the case, phenomena like the Methuselah star or ancient galaxies might be understood as consequences of interactions or overlaps with other universes. The multiverse hypothesis, though speculative, offers a way to reconcile the seemingly contradictory evidence accumulating from the JWST and other instruments. If true, it would not only reshape cosmology, but also challenge how we understand reality itself. Another alternative gaining renewed interest is the concept of a cyclic universe. According to this theory, the cosmos undergoes endless cycles of expansion and contraction, big bangs followed by big crunches. The ancient galaxies and stars seen by JWST might then be remnants or echoes of a previous cosmic cycle. If so, they could provide insight into a universe that existed before ours. UST has also uncovered evidence pointing to another puzzle: the existence of primordial black holes. These dense objects may have formed just moments after the Big Bang, and could help explain the unexpectedly rapid formation of early galaxies. Acting as gravitational seeds, they might have accelerated galaxy development. However, their existence also raises unsettling questions about what else we might be missing about the universe's early history. Dark energy, long considered a constant force, may itself be changing over time. Some recent observations suggest it could be evolving, influencing the universe's rate of expansion in ways we don't yet fully understand. If dark energy is not stable, it could help explain the rapid development of galaxies and the discrepancies in age estimates. But it also complicates our already fragile cosmological models. This opens the door to even more profound questions. At the smallest scales, where quantum mechanics rules, the very concept of time becomes unstable. It's possible that, in the early universe, quantum fluctuations influenced the formation of galaxies, or even altered how time itself flowed. These are not just theoretical ideas. They might be the key to unlocking the enigmas presented by the James Webb Telescope. From the time dilation near black holes to the quantum irregularities during the Big Bang, our models may be too simplistic to capture the true complexity of the cosmos. The James Webb Space Telescope has not only sharpened our view of the distant universe, it has also thrown the foundations of modern cosmology into question. With stars that appear older than the universe and galaxies that formed far too early, the evidence suggests we may need to completely revise our understanding of cosmic history. But this endeavor goes far beyond simply adjusting numbers. It strikes at the heart of what it means to understand our place in the universe. With every new image, every surprising measurement, JWST compels us to ask deeper questions. Could the universe truly be 26.7 billion years old? Could it be part of a larger, timeless multiverse? Or are we witnessing the remnants of a previous universe altogether? These are not just scientific questions, they are philosophical ones. They force us to reconsider what we know about time, existence, and the very nature of reality. One thing is clear: The James Webb Space Telescope is more than a scientific instrument. It is a window into the unknown, a device that challenges our assumptions and expands the horizons of human curiosity. As we stand at the edge of potentially transformative discoveries, we must be prepared not just to update our models, but to rethink them entirely. The journey is far from over, and the greatest revelations may still lie ahead.